Okay, so let's have a look at this question. How much hydrochloric acid will we need if we use 14 grams of magnesium oxide? Now, with questions like this, there's two different routes to answer them. There's the moles route and the mass route. And definitely with the new 9-to-1 curriculum, they're going to want you to know the moles route. So we're going to look at the moles route first of all. Okay, so step one, we're going to underline the substances whose mass you're given and whose mass you want to find out and calculate their MR. That's just to make sure that we don't waste time calculating MRs that we won't later need. It just concentrates our minds a little bit. Now, step two is to think, how many moles do we have at the moment? And it tells us in the question we've got 14 grams of magnesium oxide, and we know the equation for moles is moles equals mass over MR. So we can calculate the MRs using the periodic table for MgO, and I'm going to assume that you know how to do that. And when we do that, we're going to see that the MR of magnesium oxide is 40. So putting that into the equation, 14 divided by 40, it means we've got 0.35 moles of magnesium oxide. Now, step three, we want to, in this question, identify the number of moles we need. Now, I'm going to say this in a perhaps overcomplicated way, which is to take the ratio of the moles you need divided by the moles you have, which in this one is 2-to-1. Now the reason I'm doing that is if they put a more complicated question than this, say perhaps with ammonia, you're going to have to follow that route. The simpler way to think about it is to look at that equation. Okay? What that big 2 in front of the HCl is telling you is that 2 moles of HCl are going to react with 1 mole of MgO. Okay, so we know then, therefore, we've just worked out we've got 0.35 moles of MgO. So how many moles are going to react with that? Well, 2 times 0.35 moles is going to be the answer. So that's fairly straightforward. It's a 2-to-1 ratio. So we're going to take the 2 divided by 1 to give the ratio and multiply that by 0.35. And that gives us that we're going to need 0.7 moles of HCl to completely react with MgO with no excess left over. Now what we need to do now we know the moles of HCl, we can use the periodic table again to work out the MR of HCl, and therefore we can work out the mass of HCl needed to completely react with MgO. And this is, the way we do this is just bring out the same equation again, moles equals mass over MR. This time we're going to rearrange that equation, and the rearrangement of that equation is going to be moles times MR. So that's going to lead to 36.5 times 0.7, which is going to give us the answer in grams of 25.55 grams, and that is the answer. Okay, let's look at this next question. The question says, how much ammonia will we get if we want to react 14 grams of hydrogen? And you can see this time from the equation that in this reaction, 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia, which is going to make it a little bit more tricky. So we're going to do it exactly the same way as the first one. We're going to underline the substances whose mass we're given, and using the periodic table we're going to calculate their MRs, which for H2 is going to be 2 and NH3 is going to be 17. Okay, the second step is we're going to calculate the number of moles we have from the known information using the equation moles equals mass MR. We're told we've got 14 grams of hydrogen. So we're going to do 14 divided by the MR of hydrogen, which is 2. So we know we have 7 moles of hydrogen in this question. Step 3 is going to be a little bit more tricky. We've got to identify the number of moles we will get. So the ratio here of the moles we get to the moles we have is going to be 2 divided by 3. So we're going to take 2 divided by 3, which is going to be 0.666. And we're going to times that by the moles we have, which is 7. Okay, and that will tell us the amount of moles we've got of ammonia. But as the question is in grams, we're going to want to convert that to grams. So we know that 7 moles of hydrogen will result in 4.66 moles of ammonia formed. And to change that into mass, we know the moles now, we know the MR, so it's just going to be moles times MR with a simple rearrangement of that equation. So that's just going to be 4.66 times 17. So the answer is there, we're going to get, if we use 14 grams of hydrogen, we're going to get 79.3 grams of ammonia.